All right, everybody. Welcome to the 7/21/2020 classroom meeting, chapters 15, 16, and 19 question and answer session. So before I get started, let's just get into your assignment for today. Since we've already covered the 3 chapters that this unit is on, I thought I would give you guys some at-home labs to do, since chapter 15 and chapter 19 have at-home labs to do. So what you can do is you can either click on the rock candy lab and you can do the rock candy lab, or you can click on the ice cream lab and do the ice cream lab. Both of them have videos that you can watch if you don't want to actually physically do the actual making of the candy or making of the ice cream. This is between me, my wife, and my daughter made this video. So if you want to watch that, that's a lot of fun. So if say you wanted to do the rock candy lab, you just click on that. It will download it for you. It's a PDF. Boop. And as you can see, it just walks you through, tells you what you need to get if you want to actually do it. And it shows you step by step the instructions, and then it talks about the rock candy, and then it just has some questions that, asking about solute, solvent, saturated, supersaturated, that kind of stuff. But if you don't want to actually do the rock candy thing, then you can watch me and my daughter and my wife make rock candy right there, and we walk through the steps that are in the lab. If you want to do the ice cream lab, you click on this and you can download the ice cream lab PDF, and it'll pop up and it talks about how to do the ice cream lab. Pretty simple. All you got to do is answer the question down here about the molality of your ice and salt solution that you needed to get it to about -19 degrees Celsius. Now, again, if you don't have a thermometer, then you don't have to worry about that. You can just hypothetically guess the amount of ice you used, use this amount of salt and all that kind of stuff. It's just a practical application. But again, if you don't want to do it, actually physically go out and get these things, if you don't already have them, then you can just click on the video right there. Let's just say. Nope, just pick one. So you just pick a lab. So if you go over here, you'll notice that it says choose one of the files below. So you just pick one of them. That's it. If you want to make ice cream and that's fun for you, make ice cream. If you want to make rock candy and you like rock candy, make rock candy. So the rock candy recipes don't have flavors in them, so that could be something cool you add to it. But also the responses can be in a video. So like if you don't want to write this up, like if you don't want to actually turn something in and you just want to turn your cell phone on and be like, here's my rock candy I made, and then just like, here's the answers to the questions and submit that, that's fine. I set this up to where you can submit anything. So you could submit a video file, you could just submit a picture, you could submit, you could hit respond on this and type on that. So there's however you want to do it. This is really meant to be fun. This is not meant to be like your final like how to do a lab type of thing. This is there are some cool, there's lots of cool labs in all of the chapters, but we can't do them because you guys don't have glassware, you don't have chemicals or whatever. Well, for 15 and 19, we can do literally making food and candy and stuff. So let's do it, So that's what's on there. So they're pretty simple. Download one or the other. If you don't want to actually physically do it, watch the videos for one or the other. The video link wasn't working on this one, so I posted it here. And this one has the video link inside of it. So if you go to the ice cream lab and you don't want to actually make the ice cream, you can just click on the video and you can watch them make ice cream. So
I love ice cream.
There's the ice cream guy. He talks about how he's going to mix it together and the different salt solutions and all that kind of stuff. So it's not meant to be a huge deal. It's meant for you guys to take a day, work on assignment or on previous things if you want, to get ready for tomorrow's question and answer section, because tomorrow is the exam. But to also just practically try this stuff out. So that's the assignment. Easy peasy. So, are there any questions so far on all of your stuff that I can help you with? Or would you like to just go do your lab? If you want, you can type in the chat, or you can raise your hand. Yep, he's turning in. In the description, it says the question was, would we just turn in the answers to the questions if we can't actually do the lab? And the answer is yeah. You can write them on a separate sheet of paper and just take a picture of it, send it to me. You can print it out, copy it, and scan it back up. You can literally, if you're like me and you have the ability to write on things, you can just, go like this, open the file. Say you want to do the ice cream lab, you just click on that. And if you're like me and you can like write on things, then you can just click on this and scroll down and answer the question, write on it, and turn it in. Be like, hi, Mr. Sullivan. Delta TF is equal to KF MI. And then, negative 19 degrees C equals blah, 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 blah. That's it, man. That's all you'd have to do. It's not meant to be crazy, overly complicated. It's meant to be, hey, here's some actual real life applications that you can eat when you're done. So. Any other question? I will sit here and wait for your question. But that's it for the assignments for this unit. Today. After this, all you have to do is take the exam tomorrow. I'll post the exam later today. It'll come available tomorrow morning. Take it. And then that'll be the end of unit 2. And then we just have 2 more units, and they're much smaller. So this one will go pretty fast. And then this last one is just 1 day. So 1 day to take it, or say 1 day to do it, 1 day to take the test. And we'll take the final. If you're looking at our schedule, we have unit 6, I should say, is going to be today and tomorrow. So we're doing our labs today. We're doing our test tomorrow. And then on the 23rd, we're going to do chapter 17. Then we're going to do chapter 18. Then we're going to do another thing like we did today, trying to get an at-home lab going. We'll see. I might just have you guys do some other assignment. Then we'll take the test. So this is unit 6 test. Here's unit 7 test. Then we'll talk about nuclear weapons and nuclear decay. That's all chapter 25. And we'll take the chapter 25 test. And then we'll take the final exam. So pretty easy stuff coming up in terms of days where you get to, like today, where it's like, here's an activity you can do. It can take you 15 minutes if you just go online, watch the video, and then answer the questions, or you can do it at home. So it's up to you. I did the ice cream lab with my students during the distance learning at the end of the year. And while I had about 180 students, about 10 or 15 of them made the ice cream and showed it to me, and they said they had a lot of fun. So one pro tip about ice cream, if you want to do that, is to, rather than, you can eat your ice cream right away after it's frozen, but if you want to just put it in the freezer, then it will actually turn into like ice cream as you're used to, where, you know, it's kind of like more solid. So if you want to actually, you know, have ice cream for later, then just immediately put it in the freezer, let it freeze completely, and you'll be quite happy with your results. So, any questions on the content? Any of the quizzes? If you guys took the quiz yesterday, you noticed that obviously the quiz showed that the amount of content I wanted you to know versus what the book went over was a lot less, because again, the book is very, very detailed in its acid base chapters, but you guys don't need to be that. If you were interested in AP Chem, then yeah, then that'll be everything you learn in AP Chem as well, so you'll be ready for it. But AP Chem does a lot of with buffers, though. Buffer solutions. They're very important in like the medical field and whatnot, so that's why buffers are a big deal. One of the things I did as a chemist was make buffer solutions a lot because of the stuff I made, utilize them. So, but for most people, they're not really that important. The video does a really good job of explaining that. Could you do an example of a freezing point depression question? Sure. We can go straight to your classwork right here in the sample problem. If you see on here, it says colligative properties, and then it says calculations involving colligative properties. So for a typical freezing point or boiling point problem would either be like 5 or 6. So let's take a look at 5 and 6. And these ones, they made them kind of easy. So just for your guys' memory, remember that the change in the freezing point is equal to a constant times molality, which is little m, times I. And the freezing point is going to be, freezing point, because it's called freezing point depression, you take the original freezing point and you subtract the delta TF. So in this case, we're talking about water. So water's freezing point is 0. So what we need to do is find how much it's going to change, and then we can then plug in our rest of our numbers. Now, different salts give us different I's. So these two different salts are going to give us 2 different I's or whatever. And this guy isn't a salt at all. So we won't even have to worry about I for the sucrose molecule. But if we want to talk about ice cream, number 6 is a good example, because when you use rock salt sodium chloride, and you'll be putting sugar in the milk, so the milk's freezing point will change. So let's take a look at A and B of this problem. And remember that when it comes to KF for delta TB, the only difference is that we use KB times M's times I, where the boiling point, though, is going to be 100 degrees plus delta TB. So it's called freezing point depression and boiling point elevation. So here in number 5, we're going to be adding our answer. And here we're going to be subtracting our answer. And this add from 100 and this subtract from 0. And then it doesn't say it anywhere on this paper, but you can always look it up. But KF is equal to 1.86 degrees C per mol. And KB is 0.0 0.512 degrees C per mole Al. What that means is every mole per kilogram, so every mole Al, makes the freezing point or boiling point change by this much. So freezing point changes by almost 2 degrees, where boiling point only changes by 0.5 degrees. And that is because when you're going from a solid to a liquid, you're increasing the amount of hydrogen bonding, and so the temperature change is greater. But when you're going from liquid to gas, you're going to start breaking those hydrogen bonds, and so it's going to not really change much. You're actually lower the intermolecular forces. So in this case, it doesn't give us mass. Sometimes you'll have mass, like in the problem when you're doing the ice cream lab tonight, it says you have 600 grams of sodium chloride. But in this case, it just tells us the moles, and it tells us the grams of water. So that's going to be for our molality, and that's italicized little m. There we go. Here's a better italicized little m. And, oops. There we go. Remember that little m, the controls are in the same spot, is moles over kilograms of solvent. And so we don't have kilograms, we have grams, so we need to move this. And remember, the conversion is just simply move the decimal 3 times. So what we have is 0.35 moles over 0.9 kilograms. So get out our calculator. 0.35 divided by 0.9. Bunch of sig figs in there, but it doesn't really matter. And that's going to give us 0.39 molal. And it says find the freezing points of the following solutions. So now that we have molal, we can plug it into our equation over here. So delta TF, so we need to know the change in our temperature, is going to be 1.86 degrees C per molal. We have 0.39 molal. And now we need I. So what's I? I is based off of the salt, and it's count the ions. So we're going to split this up into the number of ions that it has. So we have 2 ions. And so that means I, in this case, will equal 2. In the next problem, you'll notice I equals 1, because in sugar, there are no ions, and so it just stays one thing. Where this does not stay one thing, it becomes 2 things, sodium ions and chlorine ions. And remember that the freezing point and the boiling point change because we're changing the amount of intermolecular forces. Sugar only adds 1 thing, so it only adds 1 amount of intermolecular forces, where sodium chloride adds 2 things, so it adds twice as much intermolecular forces. And that's why we have to multiply it by 2 over here for the equation. So now we just plug in our number to find how much the freezing point will change. Notice that this will be a positive number, but our answer will be negative because it's 0 minus delta TF. So let's plug in our numbers here. There's our molality. We can multiply this by 1.86 and then multiply it by 2. So we're going to get 1.45 degrees of change. Degrees C. So then our new freezing point will be 0 degrees C minus 1.45 degrees C. That gives us negative 1.45 degrees C. So that very small amount of salt did not change the temperature of our ice very much. If the ice was at 0 degrees C, though, it would melt because it now wants to be a liquid at 0 rather than be a solid. It wants to be a liquid at negative 1.45. So for you guys, though, you're going to be plugging in, your molality. You'll have to figure out how many grams, 600 grams, how many grams of, or how many moles is that of salt, because salt is sodium chloride. But the I will be the same. It'll be 2. And the KF will be the same. It'll be 1.86. So the only really difference will be the molality. And in the problem, it tells you in the paper, it says, just guess how much salt you're going to, or how much ice you're going to use. So if you have a gallon bag And, you know, you fill the gallon bag with ice and it's like, yeah, it feels like 4 pounds. Well, that's 2 kilograms. So you can just say 2 kilograms. So like, it's just, you can just, it's meant to be inaccurate, just kind of have fun, make ice cream and kind of think about the science behind it while you're making it. All right, so we can do the next problem now where we have an I equals 1. This is why we use so much salt when we make ice cream, is because we also have to overcome the fact that the ice cream is full of sugar and fat and all kinds of stuff that are all doing colligative properties to the water solution. So its freezing point already of milk is already lower than 0, but not by much. And so we just need to overcome it by quite a bit. And that's why we usually like to go about -18 is usually what I tell my students in class. The paper says -19, and you know, either one is fine. All right, so now we have a mass of our sugar, and we do have a mass of water, and so we need to figure out our molality again. So the very first thing we're going to do is we're going to turn the grams of sugar into moles of sugar. So we're going to have to find the molar mass of sucrose because we want to turn that into moles of the C12H22O11. So that's fructose and glucose stuck together. That's what we call sucrose, table sugar. So what we're going to need to do is need to do the molar mass of this. So that's going to be carbon is 12.0 grams per mole, and we have 12 of those. Hydrogen is 1.0, and we have 22 of those, and then oxygen is 16.0, and we have 11 of those, and so we're going to add that all up. So 12 times 12, so 144, plus 22, because 1 times 22 is 22, and then plus, in parentheses, 16 times 11 should be 342. That's going to give us our moles. So 126 divided by 342. 0.37. Okay. So now our molality, our little m, is going to be equal to 0.37 moles divided by the mass of water in kilograms. This is in grams, so we need to move our decimal 3 places. So that gives us 2.5 kilograms. So take our answer divided by 2.5. And we get a mole of 0.15. Mole. So now it's just like the previous problem, but there's one big difference. The delta TF is still going to be the same. We're still going to have KF, and we're still going to multiply that by the molality. But now, instead of multiplying this by I, this is not ionic. We know it's not ionic because carbon, hydrogen, and oxygen are all non-metals. Also, that does not add up to 0 if we wanted it to. This would all be +1. This would all be -2. So those guys right there already are pretty close to balancing each other out. So what's the carbon doing, right? So yeah. Another way to check to see if something is ionic or not is, does the charges add up to 0? And the answer is they do not. So this is not ionic. This is covalent. And so because this is covalent, it will not ionize. It won't split up. And so you'll only have one thing. So our I here is 1. So we can just ignore it. So now we can find our change in our freezing point. And that's going to be 1.86 degrees C per mole. And then we found our mole to be 0.15 mole, and our I is 1 because of the fact that this is not ionic. So then we just take our answer that we got in our calculator, which is still sitting there, and now we multiply it by 1.86, and that gives us a change in temperature of 0.27 degrees C. And remember that the freezing point is equal to 0 degrees C minus delta TF. You can also just write, negative delta TF. So our new freezing point is going to be negative 0.27 degrees C. Not enough to make ice cream, that's for sure. But also, if this was your ice cream mixture that you were using, and you were pouring the salt, that much sugar into the water, you'll notice that it didn't really affect the change of the temperature very much. And so you won't have to worry about that when you're making your ice cream. And remember, there's no difference between the boiling point and freezing point, except for you just use a different constant, and instead of going down, you go up. That's it. There we go. All right. Anything else? Happy to answer any and all questions you have. Okay, everybody. If you think of anything else, just go ahead, shoot me a message. I'll come on, help you out with anything you want to do. But that's it for today.